Welcome back, guys, to the next video lesson, Properties of Numbers. This lesson is going to be a little bit different than the other ones. We're almost taking a break from algebra and previewing geometry. And what I mean by that is we're going to be learning a lot about the different reasons of why we can do things in math. And that's very much geometry topic. Now this section is going to take things that you already know how to do math-wise and is going to be giving them names so that you know what it is you're doing and you know why it actually works. So it might seem a little abstract, I guess would be the best word, but it is important, especially later on when you get to geometry, that you know why these things work. So here we go. It's going to be mainly definitions. So at any point, pause the video, write them down, and in general, just make sure that you have good examples and good definitions. Here we go. Now, properties of equality and identity. Equality means that things are going to be the same. All right. Identity, so this is going to be equal signs. So one thing is the same as another thing. Identity is a very, very similar word. That's like 1 is equal to 1. Okay, so it's going to say not only is it equal in value, but it is the exact same thing. Here we go. First up, reflexive property. Now, reflexive property means that you have the exact same thing on either side of the equal sign. So if you were to draw a dotted line down the equal sign, and it would be like a mirror, meaning the value of what's on one side is the exact same as what is on the other. Same thing for this example. I draw my dotted line, change color so you can see it better. And you have 4 plus 7 on one side, reflects on the other side, 7 plus 4. So you can see order doesn't matter. What matters is the value of one side is the same as the value of the other side. Now, symmetric property is very, very similar. All of these are going to be pretty similar, just letting you know that one. But symmetric property is different because in reflexive property, you have the same numbers on both sides. Symmetric property says that two things that are different still equal each other. So 8 is the same as 2 plus 6. Okay, the value is still the same even though the sides look different. And that's the big difference between reflexive and symmetric. Reflexive, it has to be the same. It's that mirror. Symmetric just says that even though they look different, they are the same thing. The next property on our list is transitive property. And this one's actually a little easier to see in example form. So I'm going to do an example under the name over here. This one says that if A equals B and B equals C, then A equals C. What this is it's kind of like linking events together. Okay, you're connecting events and you're realizing that if there's a clear connection, then the last thing equals, or the first thing equals the last thing. And you can see that also over here with numbers. But this one's actually a little easier to see with letters. And the last one for this slide is the substitutive property. Substitution is very similar to transitive, but where transitive links information in a chain. So you have A, then B, then you have B, then C, then you have A, then C. Substitution is a bit different. With substitution, you're basically told that A already equals C, and therefore you can go ahead and plug it in and use it. Okay, so transitive, you're setting up the fact that A equals C. Substitution tells you straight up, A equals C, now let's keep going and move on with the problem. And that's going to be the biggest difference between these two properties. Next slide. The addition properties. So that slide was all about equal signs. This side is all about adding. Two big vocab words would be identity and inverse. Remember, identity is it's the exact same thing. Inverse means it is almost the opposite. Now this is when we get into naming things you already know. So bear in mind that you already know how to do these things in math. We're just now naming the process. So the additive identity is when any number, when added to 0, equals itself. Okay, the example has 2. 2 plus 0 equals 2, or 0 plus 2 equals 2. The big thing here is this plus 0 thing. It is saying that any number added to 0 is itself, which is common sense. I mean, if you add 0 to something, it doesn't do anything to it. Now, the additive inverse property is slightly different. It is when you add a number and its opposite. So you have the number plus its negative number. It's going to equal 0. So the first one, additive identity, means anything plus 0 is itself. The second one is anything plus its opposite is equal to 0. Now the additive inverse is where we get subtraction. Okay, but it's subtraction of the same number, this 4 minus 4 example. Okay, because anytime you subtract two numbers, it can be rewritten as plus a negative. So if I have 5 minus 3, I can rewrite this as 5 plus a negative 3. Okay? But what makes this the additive inverse is you have to have the exact same number, and it's negative. Okay. So these are the addition properties, and you can see that from the addition properties, you actually get subtraction. The same thing goes for the multiplication properties. Okay. Again, you have multiplicative identity, multiplicative property of 0, and the inverse. So we're going to be playing around with zeros and ones in this slide. Multiplicative identity is where you get the same number you start with. Identity means whatever number you start with, you have it at the end. So 14 times 1 is going to be itself. It doesn't matter where that 1 is. The multiplicative property of 0 is just a fancy way of saying anything times 0 is 0. That's it. Doesn't matter where 0 is in the equation. If you multiply a number times 0, you're going to get 0. Multiplicative inverse is what we went over last class, or last PowerPoint. Now, last PowerPoint, we went over a reciprocal, where if we had 3 over 4, and we multiplied it to 4 over 3, that would give us a 1. These two numbers are reciprocals. Okay? This whole process is a multiplicative inverse, where you multiply something by the reciprocal and you get 1. This is just fancy writing for saying that for every number where the denominator is not 0, you will have this situation. Now, if you're scratching your head and going, what is this all for? Again, the reason why we're going over this is so that you understand why you can do what you're doing. This is very much a geometry lesson because explaining and proving why you can do what you're doing is a geometry concept. But it is important that you understand here in algebra how to describe and explain the things you're doing. Number one comment I get all the time is that, Ms. Stockton, I know what to do, I just don't know how to explain it. Here's where we learn how to explain things, or learn how to explain things in a different way. All right, so now we're going to use these properties. As you can see, the problem is already solved for us. This is the original problem. Here is the answer. Which means that the point of this example is not for you to solve the problem, it is to describe what is happening. So we are going to use the principles and the properties that we just learned to explain why this is the correct answer. Okay. So this first one, in this first step, okay, you have that the difference is right here. Order of operations, you have 4 minus 3 gives us 1. So what happened to give us 1? This right here is substitution. Whenever, oops, that's really bad writing, but substitution. Whenever you replace a value with something else, that is substitution. Okay, so we at first had 4 minus 3 over here. Nope, erase, go away. Okay, we had first had 4 minus 3, and now we have 1. We have replaced 1 with 4 minus 3. Our next step, so how did we get from, and I'll use a different color, how did we get from here to here? Well, the change is that we no longer have the parentheses. We multiplied 7 times 1, and we got 7. So this is the multiplicative identity. And I am not going to write all that out. So I'm going to abbreviate a bit. Okay, multiplicative identity. 7 times 1 equals 7. Now from here to here, this happened. We multiplied two things together and got 1. This means that we used the multiplicative inverse property, because we multiplied a number by its reciprocal. Okay. Now from here to here, this happened. 7 minus 1. Now, we don't get a 1, we don't get a 0, we don't get the original number we started with. Those are all hints that you're back to substitution. You have replaced a value with something different. And then same thing from here to here. You don't get a 1, you don't get a 0, you don't get the number you started with. So clearly we have substituted a value in for an expression. Okay? These properties take a bit of getting used to, but it still is just you breaking down and explaining why you can do things that you've been doing for a while. And here it is. Here's the answer. Now this page is actually in the book, so if you are confused as to my explanation, there are two things you can do about it. Number one, you can ask me in class. Always a great option. Number two, you can go to the book, go to this section. It is chapter 1.3, and you can look it up. All right, look up the book, look up the explanation, see if the book's explanation makes any more sense than mine did. Now you're going to do these two on your own, but I'm going to split up the answers. So I will pause the video. When it starts again, you'll see 1A, and then it will pause and start again for 1B. That way you can do one at a time without having to worry about seeing both answers all at once. All right, here we go for 1A. So here are the answers to 1A. You can see I underlined the change and then wrote the step. Don't forget it goes what got you from the first to the second step, and then what got you from the second to the third step. This is the process. Okay, you're not describing what's happening on that line, and I'll show you a different color. You're not describing that on the same line. It's always going to be, I'm changing colors. It's always going to be this is this explanation. This is this one's explanation. Okay? You're always going to be explaining the line above, essentially. All right, go for 1B. And there are your answers for 1B. Okay. Both of these, if you can tell, are questions from the book. So again, if my explanation is not helping you, go ahead, look in the book. If that doesn't help, make sure you ask in class. We are almost done. We have 2 more properties left. The commutative property means, as it says right here, back and forth. Okay, think commute. You commute from school, you go back and forth from school. Now these properties, or this property, only works for addition and multiplication. Okay, this whole PowerPoint, if you've noticed, has been about adding and multiplying, even though there were instances where it could have been subtraction. But the commutative property only works for adding and subtracting, and the reason is that it states that things can move around. Another way to put this is if we were to use the equal sign and replace it with the words the same as. So 4 plus 8 is the same as 8 plus 4. Okay, that is a true statement. But it is a statement that only works for addition. If I were to try to put subtraction in here, and I said that 4 minus 8 is the same as 8 minus 4, okay, this one is not a true statement. This over here gives me negative 4. This over here gives me a positive 4. Those two numbers are not the same. Therefore, you can't put an equal sign between them. This statement doesn't work. Actually, I'll leave it there. Multiplication means the exact same thing. 7 times 11 is the same as 11 times 7. It doesn't matter what number comes first or what number comes second. With multiplication, it's going to be the exact same thing. That would not be the same if it was division. Writing over here, oops, need a pen. 7 divided by 11 is certainly not the same as 11 minus 7, or 11 divided by 7. You're going to get two different numbers in that example. And that's the number one important thing about the commutative property, is that the order doesn't matter. The order does not matter if you are adding and multiplying. It doesn't matter which number comes first or second. It does matter in subtraction and division, which is why you can't use it then. The last property is the associative property. Now this has to do with grouping symbols, as you can probably read and already see. This property is very similar to the commutative property in that order doesn't matter. And like the commutative property, the value stays the same in the first version and in the second version. So for this first example, again with the pen. In this first example, you have parentheses, and I'll rewrite it down here so you can see it better. You have parentheses around the 3 and the 5. And on the other side of the equation, you have parentheses around the 5 and the 7. Okay, the parentheses have clearly moved. However, if you were to add this up, if you were to solve and go all the way down, so this is 8 plus 7, this is 3 plus 12, this is 15, this is 15. Those two things still equal each other. Even though the parentheses were in different spots, you still got the same answer. The same thing's going to happen if you play out the multiplication problem. The associative property states that no matter where your grouping symbols are, your value will stay the same. Okay? This, again, only works when you're adding and multiplying, because those are the only two properties where order doesn't really matter, and you can still get the same value even if you do it in a different order. You're not going to get the same effect if you subtract things and divide things, because big numbers and small numbers matter over there. And there you have it. This is the last property of the PowerPoint. This may have been a bit weird of a lesson, but again, the point of this lesson is to explain why things exist. Because when you get later on into math, you can't always take these things for granted. So please pay attention to the definitions, make sure you know what the differences between the properties are, and I will see you in class.